All right, it is time to talk about perms. So we're going to talk about permutations. I might abbreviate them perms. No, they are not the same thing as these perms. These perms, apparently I learned that perm stands for permanent hairstyle or permanent wave. There is some disagreement on the internet, so if you know, you let me know. I'm not, to be honest, entirely sure what a perm is, but I don't need one. So let's get into it. What's an algorithm for a permutation? And specifically, we're going to talk about algorithms for enumerating permutations. Remember, there's a difference between counting something and enumerating something. In the last video, we did counting permutations. We said, how many of these are there? But enumerating something is, how can we go through and list? How can we find every single one? How can we systematically go through it? And that's what we're going to be doing here. So here's an algorithm. Oh, I didn't change the color. Oh, well, I'm committed now. This algorithm will be in blue today. A permutation algorithm for n objects. So first off, if n equals 1, you're being very silly, stop. If there's only one object, there's only one order, okay? So don't do this algorithm. You don't need to. We're done. If n equals 1, there's no algorithm that you need to do. There's no way to order things. So why are you even here if n equals 1? But let's say n's not equal 1, and you do have a reason to be here. So otherwise, and I'm going to do my favorite thing to do is I'm going to introduce the algorithm while we're solving a problem. Okay, so I'm going to go to the next page, and with my program bugging out a little bit, this might be a little obnoxious, but let's see if it works. I'm going to go to my next page and say, all right, let's unscramble the word TMA. And you probably know where this is going. You can probably unscramble words. You're probably very good at this. But let's just see what the algorithm looks like. So what is n? N equals 4. There are 4 characters that we are reordering. So great. We have a reason to be here. So if we don't have n equals 1, what are we going to do? We're going to remove one object and then find the permutations of the remaining objects. And then there's more steps after that, but let's do one thing at a time. So let's remove an object. So if we remove t, right, we want all the permutations of TMA. Let's remove t. Let's remove any, it doesn't matter what you remove any object. So now we need to find all the permutations of ma. Well, to do that, well, now n equals 3. We do the algorithm again. This is another recursive algorithm. It just breaks the problem into smaller problems. Okay, so let's remove, again, you can remove anything you want. Let's remove m. Now we need to find all the permutations of AH. And again, you can get things down to 1. And again, technically, I should be a little bit more precise in this. If n equals 1, then there's only one permutation. Right? There's only one order. So we again remove one more. We can remove A. Great. So that's the first step of this algorithm. It's just removing things order by order, removing any character. I just did the first one order by order. That's the first step of the algorithm. And now let's make this algorithm a little bit more interesting. What do you do once you have done this? You insert the removed letter. Sorry, not removed letter. That's the removed object, because this works for any permutation, not just words, not just word unscrambling, any permutation. Insert the removed object in every possible position. Okay, so we're essentially going to go backwards now. We've gone forward for all of this. Now we've gone over here, we removed A. Let's insert A in every possible position. So A can go before the H, which we already did, or A can go after the H. And actually, what I'm going to do, I'm going to write that down here. And you'll see why. Because now we know there are two permutations of these two letters. And then what did we do before that? We removed M. So now let's insert M into every possible location. So for this permutation, M could go before, just like we have. M could go in the middle. And again, I'm going to space these out a little bit. M could go in the middle, or M could go at the end. All right. That sounded better in my head. M could go at the end. End. This is just getting worse and worse. And then again, same with this one. M could go at the beginning. M ha. M could go in the middle. Or M could go at the end. And go ham. And then again, we could continue this algorithm. We remove the T. So for each one of these, we're going to put T at the beginning, T here, T here, T here. So for each one of these, there's going to be 4 different things. So we got T at the beginning. That's what that looks like. We have T at the middle. Hopefully you're getting the idea. We have T in the third one. Ah! We have T at the fourth one. Sorry, why did I make that sound? It's math. Wow, how fun. All right, and there's going to be 4 for each one of these. All right, so like this one leads to 4. This one is going to have 4 more, right? This one's going to have 4 more, blah, blah, blah. So there's going to be a ton of these, dot, dot, dot. I'm not doing all of these. That's what the algorithm looks like. All right, so that's one algorithm to permutate. This is one algorithm to enumerate a permutation. You just break it down into smaller problems, and then you find all the permutations of those smaller problems. And that's what we got here. Let me know if you have any questions. We got another algorithm in the next video.